Okay, we're gonna go through some Mikey Smith stuff. This one is he calls an observatory. He used to do this a lot, but he hasn't done it so much this year. But we're gonna listen to him calling in the observatory. I think he gets a secretary first, and then there's an astronomer or a programmer in the observatory, and he talks to them. So we're going to just listen to this for a while. Okay, let's just start.
Maybe Roger can go kick down the doors for me. Of course, nobody's really actually interested in going to these places ever, so they're not really busy. So let's try.
It depends on the observatory and what's going on in the night sky. If you have like a comet in the sky, people are more interested in going to an observatory. So if there's something interesting going in the sky and getting a lot of press, you get a lot more people going to the observatory. I did a like a tour guide thing for one university where we normally just got like a kids class and 1 hour, and then a university class in the next hour. They were there for coursework, and there was a maximum of about 10 people in the observatory, so they got stretched out. But when Hail Bob or Hockey Tucky came around, this was like in the late 90s, there was more demand, and we actually had to double the nights. So instead of just Tuesdays and Thursdays, it was, I think, Monday, Tuesday, Wednesday, and Thursday. So we actually had quite a bit of traffic into the observatory for those events. So yes, it does vary. So, but it depends on people's interest and what's going on in the sky. Okay, we'll go back to Mikey.
Record your message at the tone. When you are finished, hang up or press pound for more options.
Hi, Samantha. It's Mike calling from Canada. I've been doing a little bit of research here, and I'm phoning around to find out if anybody, your buddies and you, NASA, have ever recorded a video of a so-called galaxy. Because I've been watching the skies through my ginormous binoculars, and I don't see no galaxies. So we've got that up on the hill there. I need a phone number here, boys. What's it called here? University of Texas Observatory. Nice.
McDonald Observatory Information Desk, may I help you?
Oh, beautiful. You're the actual inside the observatory itself?
Well, I'm at the visitor center.
Oh, okay. Is the observatory actually open like tonight?
No, not tonight.
Oh, okay.
It's only open we're open Tuesday, Friday, and Saturday night.
Okay, cool. And is it so are you part of the astronomy group there? Like, would you know anything about stars if I asked you some questions?
I'll do my best, but no, I'm not.
Okay.
The astronomy group.
Yeah, I'm just wondering if anybody there has actually recorded a video of a galaxy, because it seems like everything that you get from NASA or from any astronomer, it's always a picture or a image computer generated on a computer. I'm wondering if they have any videos of, because I've never seen a galaxy myself, because I've been looking at the stars for about 3 years now, and I have never seen a actual galaxy. So I'm just wondering.
Okay, when you take an image, you can take a longer exposure and you can stack them on top of each other and get better detail. That's why we take images. Also, taking a movie of a galaxy won't show anything. It takes about 224 million years for the sun to go around the Milky Way. So to see like M51 to spiral, it'll take hundreds of millions of years. Plus, also, when you take video, you also have a chance of showing atmospheric distortion in your images. And a lot of his images have atmospheric distortion. They're not images, they're movies. And they have a lot of atmospheric distortion, and that's why. Also, you got to feel sorry for the receptionists or secretaries who get these calls. Mikey's probably not the only one that calls them. But yeah, they have to take these weird calls. And also, the McDonald Observatory is actually where a guy named Gerald Kuiper did research. He came up with the Kuiper belt and other planetary physics stuff. And one of his students was Carl Sagan. So we'll go back to Mikey.
You from?
I don't know that they've ever done video footage.
Yeah.
Yeah, hang on.
Yeah,
Let
for
me-
sure.
I've got a programs person here.
Yeah, sure. Oh. Of course, it's a programmer.
Having a programmer at a observatory is not very unusual. I don't really know. I've only been around a couple telescopes, so but one observatory I know of, Burt Gaffney in Halifax, was actually ran by a programmer, Dave Lane. He actually worked in programming that ran the telescope. And so he wrote software that built the telescope. The programmer there probably wrote from some software that helps run the telescope, helps process the analysis of the inputs. The still elements are probably back at the university, probably teaching classes or doing data analysis or marking assignments and marking labs or grad students doing that. And the grad students, since they have to do observation runs, they probably are resting up during the day. So having a programmer there and no astronomers there is probably not very unusual, and it's nothing suspicious. Okay, we'll go back to Mike.
Phoning around to some of the observatories because I've been watching the skies for about 3 years or so with my big binoculars, and so I use my cell phone to zoom into the sky, and I've never recorded or seen a galaxy, so I'm just kind of wondering why they're not there, because I've recorded the entire sky from horizon to horizon, or should I say curvizon to curvizon. Because the horizon is actually horizontal, but so I'm just wondering, do you actually you're a like do you edit your stuff to put in the galaxies like with computer software?
So looking into galaxies is very, very hard to do. You need a very, very big telescope, like our research telescopes and special instruments, to get close enough. Even then, it's hard to look at
Like what
individual stars in a galaxy.
Okay, but I'm getting so I've been recording stars. I'm recording videos of stars with quite high definition actually, because according to me, they're actually quite very close. I do not need the use of a ginormous telescope because the only thing that allows you to do is see more of the sky. I don't want to see more of the sky. I want to see less. I want to see it in more detail. So that's why I use binoculars. And I've noticed that there is no depth to the stars. They're all at the same level.
Yeah.
Yeah. Well,
everything is so far away.
No.
for visual focus, it's impossible. You would need a very, very long lens to get depth at that level, to get like one star in focus and have like bokeh in the background with other stars.
Yeah, no, I'm actually getting them like side by side, and like there's no star, like the star Sirius. There's no stars behind it. They're all beside it. So I thought there was, yeah, but there's stars in between here and the sun, correct?
No.
Oh,
The sun is
exactly.
is 93 million miles away. So the closest star to our solar system, like our sun and all the planets, the closest star to that is 4 light years away. A light year is 6 trillion miles.
And how would we observe that, like, or measure that, or confirm that? How about that? How would we confirm that?
So for closer things like that, astronomers use a thing called stellar parallax. So we orbit the sun, and there's a lot of space between the sun, right? That will change our perspective of stars compared to each other. So it's like when you drive down a road, right? And the grass and stuff that's on the side of the road is moving a lot faster than, let's say, the mountain in the background, like that's far away.
Yeah.
Okay, what a telescope actually does is actually allows you to see more detail in an image. There's a criterion called the Rayleigh criterion, which gives you the resolution that you're able to see, which is 1.22 times the wavelength of the light you're looking at divided by the diameter of the telescope. So the bigger the telescope, smaller detail. Smaller the wavelength, smaller detail. Like optical telescopes, you can see really small detail with like a meter telescope, but like radio, like optical is like 10 to the 9. Optical is 10 to the minus 6 meters, and radio is around a meter. So if you have a meter radio telescope, it doesn't really give you that great detail. But if you have one that you can spread out over tens of meters or hundreds of meters or even kilometers, you get to see better detail. So that's what telescopes do. They actually give you better detail. This is just Mikey not knowing how anything works. Okay, there's another section coming right up, and that will take us to the end. Okay, one way to see galaxies is a crowd. You're in the crowd, and you can only see the people very close to you, such as, and in our galaxy, you can just see the stars within, I think, about 6,000 light years, and then you can just see points further out. And that's like being in a crowd. You can only see the people around you, and you don't really see the people far off in the distance. But if you go up on top of the crowd and look down, you can see you're in a crowd of people. That's how the galaxy kind of works. We can see the far distance of the galaxy on the far side because we have radio telescopes that can see wavelengths that go through a lot of the stuff between us and them. There's the 21 centimeter line. Like this happens when electrons flip in hydrogen atoms and produces a little radio frequency. It's actually the same concept that MRIs are based off of. And there's other ways of determining distance besides parallax. There's if you compare the brightness of stars and set a certain distance and compare it to that distance, you can figure out the brightness at that distance. You can figure out how far away an object is. And for galaxies, there's such things as Cepheid variables. These are variable type star. These are variable stars that are change brightness, and they're how fast they change their brightness is dependent on how big they are and how bright they are. And you can figure out how far they are by the period of the change of brightness. There's certain red giant stars when they transition from red giant stars go from the main sequence to a red giant stage, and when they finally change to the red giant stage, they change brightness in a certain way. You can determine how far away a star is from that. So there's there's all kinds of ways of figuring out how far things are in the universe. So I sometimes thought it would be nice to be on the other side of this call while Mikey is doing his faces and stuff, and I know he's doing his faces by watching them, and go, "Hey, Mikey, I see you doing your faces. Can you have a serious conversation?" But okay, I think that's going to be it for this video. I hope everybody has a good day, and see you next time.